Hello, today I will show you how to create reducer in Autodesk Revit using two different ways. The first way with the higher precision but lower functionality, and the second way with the lower precision but higher functionality. What I mean lower precision but higher functionality is that when we will deal with the function as justify, it will work totally fine, but with one minor disadvantage. It will have lower precision in some cases when the difference between the outside diameters of the pipelines are different. For example, here. It's a really minor, and for one of you maybe it wouldn't be that important, but still it will be good to mention. I would suggest to start first one, higher precision and lower functionality, because it contains all the basic geometry, basic parameters, basic connection between the lookup table, and then we will modify this family to work with justify function, so have full functionality. Let's jump to the family creation itself. What I will do, I will open family from the previous tutorial, elbow dummy. I will clear it almost completely from point of the geometry and from point of the lookup table. Now we'll resave it as a new family. I'll save it with the name of the reducer dummy. Here, what we need to do now is to add a bunch of additional parameters, because as all of us knows, we need to have a second nominal diameter and second outside diameter. To manage it, in the previous lesson we did create those parameters already, so the only thing that we need to do is to add them to the project. There'll be parameter of instance from the shared parameters, and here we need to select nominal diameter second, length dimensions, totally fine. And outside diameter second. Also, the thing that we need to do to add thickness on the second connector. Correct. It will be also parameter of an instance, and I think that's it property wise. Also, we have coefficient, and one additional parameter that we're going to add is the type. Yeah, I think it will be good to add, but this property will be important for the first option of the family. So as we're going to start with that, then we will use it. And that's it. Now let's jump to the basic geometry that we're going to create. We need one reference plane. Then we need to add a dimension. Then to this dimension we will give the label. We will give a label of length. For this purpose, I will also suggest to use shared parameters property. And now what we're gonna do, we will create the shape of the reducer using swept blend. But before, we will make a small modification to the profile that we did create for elbow. And for that purpose, let's click on edit and remove what we did before. The thing with the sweep blend, it is not possible to create the shape that been based on the profile that been created by two objects. It's sort of function limitation. So what we need to do, we need to create a circle using one single line. And for that purpose, what I will suggest you to do is to draw two circles using center ends arcs instrument. Something like that, for example. And the second arc will be the same. But the only thing that I need to change is the diameter. Okay, let it be 160. Now let's set one additional item as a reference plane. This reference plane will show us a sort of welding seam on the element. I will call it A, so it will be the same. Let's extend it to the reference plane and click on the lock. Oh, wrong one. Up to here. This one we will fix on that surface. Not on that plane. Yeah, it's easy to make like that. And then what we're gonna add is 2 lines. And now, as you see, what we can see on the screen is that we've created the round shape, external and internal diameter, using one single line. We do not have any kind of breaks here, and that's why it will work in a decent manner. Then I need to change this parameter. I'll assign a label of diameter external. For this one I will assign a label of diameter internal. And for value of the angle I will add 0.03 as a 0.3 as a minimum value that is possible in this case. Now what we need to do, we need to load it back, but before, let's resave it with a different name. In my case it will be reducer profile. Let's save it in such a way. Now let's load back it our family. Great. Now what we need to do is to remove the previous shape of profile, and here we need to reassign the properties. First it will be first face. Oh, sorry. We need diameter. Outer diameter, thickness 1. And second, of course, we can also switch it here, but yeah, it doesn't really matter. Here it will select thickness 2. Okay. And now what we need to do, we need to place swept bend using sketch path, but before we need to add one property here, like height offset. By default, this property is not available here, but once we will change the type of the object from elbow to transition, it will appear. Height and width offset. But height offset we'll use a bit later in the next step, but now let's jump to the geometry. We need to indicate the path, lock it to the reference planes, select the profile for the first face, and select the profile for the second face. Okay, now as you see, we've created already looks like reducer item, this 3D geometry. An additional thing that we will do is we will add a rotation 90° here and 90° here. Oh no, okay. Minus 90° and minus 90°. So the welding seam will be at the bottom, but it doesn't really matter, it's up to you. And then we'll indicate horizontal offset for profile fill. And this horizontal offset height, will be used in case when we need reducer eccentric. Let's assign first connector to work plane, revert it, and the second one let's also assign to the work plane. Oh, okay, most likely it's too low. Or too high. This property, let's also add offset height. Then it will be equal, or it will move simultaneously. Perfect. Now let's change it to diameter 1 and nominal diameter 2. And that's it. Geometry is ready. Yeah, do not forget to connect them. And reassign and ensure that this connector on the left will be used as a primary one. The last thing is that we need to change the system classification to sitting, so there will be no calculation involved. And that's it, geometry wise. Now let's jump to the lookup table. I've created it in advance. What I will do now, I will show you, or I will explain you the critical items that you need to consider during the creation of the lookup table in case of reducers. The main thing will be is that when you're dealing with the reducer, it will be not sufficient just to indicate the DN1 and DN2 only once. Because what's the problem here? Once it will be the case that the DN1 will be lower than DN2, then it will lead to failure because in this table it wasn't mentioned. To solve this issue, we need to do a very easy thing, and in the end of the table we need to just switch them in places. So DN1 will be the lowest one and DN2 will be the highest one. That's quite different from the second row. The same we need to do for outside diameter and for the thickness. Length will remain the same and the weight also will be still the same. What I will suggest you to add also is two different types of the description. The first description will be responsible for the first description will be assigned to reducer concentric, and the second description will be assigned to reducer eccentric. For the rest, it's all the same: standard, material, and pipe spec. In our case, it always will be dummy. Weight I have calculated in advance also, and now let's just load it back. Now let's import back our lookup table. Yes, Yes, okay. And as it was mentioned in the previous tutorial, we need to specify specific expression to make sure that lookup table will be used. And that's how it looks like. First, it will be the expression of the function. It will be size lookup. Then the name of the table, reference table in our case, it will be reducers dummy. Then name of the column from the lookup table where we will search the value of DN1 and lookup parameters. In our case, it will be DN1 and DN2. Let's make the same for the rest of the properties. Apply. That's it. Now, let's set additional expression. Let's modify, then it will be clear. Reducer type, let's call it. In case of 1, it will be concentric reducer, and in case of 2, it will be eccentric reducer. I will show you how it works in a couple of minutes once we've finished with this family. Okay. Ah, yes, completely forgot. We need also to fill in weight property. Yeah, like that. And now let's define the offset height. Offset height will be calculated based on the type. Height will be calculated based on the type of the reducer. So when it is reducer concentric, but once it is eccentric reducer, we need to define the value of the offset height. Let's define the expression for coefficient that will help us to define this value. First, let's enter absolute. So it will always give us a positive value. Then we need to specify. Okay, let's copy paste. Let's copy the name first. Then let's specify s. And then it will come to the DN1. Then we need to subtract DN2. And divide this value by 2. Then it will be coefficient f. So basically this is the value that we need to enter when we would like to have reducer type equal to eccentric. We need to write another expression using function if reducer type equal to, so it is equal to eccentric, then use value of coefficient 1, and if it is equal to 1, then use value 0 millimeters. Great. Apply. And now what we see here, then that in case of when reducer type is equal to 1, we have the concentric reducer, and once we will change the value to 2, the expression will work, and in the model we will have the concentric reducer. Let's load it to the project and check how it works. Let's load it to our project. Let's duplicate existing type of the pipe. In type of the pipe, we will reassign existing transition to reducer dummy. Reducer dummy, okay, apply. Great. And let's check this out. We will go from 150 to 200. Yeah, and it works almost perfectly fine. Yeah, but only almost. Ah, yes, completely forgot. Before to load it, we need to define the default value, and it will be better if it will, in case of the item with the higher precision, it always will be equal to 1. So it always should be concentric one. Let's reload it. System pipe diametry 200 to 150. Yeah, perfectly fine. Yes. And once the value is changed to 2, reducer type will be changed to eccentric. Yeah, one thing that is still missing is that we need to define the right way how to specify the description. And in this particular case, it will be a simple expression. If. Okay, let's make it a bit easier for us. If reducer type is equal 1, then it should be description of the concentric reducer, and if it will be second, then it should be equal to eccentric reducer. And let's close the bracket. Yes, great. And let's modify here. Yeah, and as you see, it works totally perfect. And this is it basically. Next time I will show you how to modify this family to ensure that the justify function will work when the family is loaded into the project. And thank you for watching, and see you next time.